Ya, nggak suara aku ya.
So, Pak Ziki aman?
Lagi koneksi ini nggak seberapa banter lagi. Anu ya, nggak putus-putus Pak ya?
Nggak putus-putus kok, aman.
Oke. Prof Gabriel sudah waiting ini. Mau dimasukin enggak? Besti? Oke.
Ya, halo. Sorry.
Ya, Bu.
Tes, suara saya masuk.
Ya, Bu, aman, Bu. Halo?
Halo, ya.
Masuk,
Oke,
Bu. Ya.
tes.
Okay, it's working now. Hello, everybody.
Halo Gabriel.
Hello, Mohammed.
Profesor Gabriel.
Halo,
Nice.
how are you?
Hello, Esti.
Hi, Gabriel.
Nice,
It's
nice
morning there,
nice.
guys.
Can you say it again?
It's still morning in Bremen now.
That's right. Good morning. Well, good afternoon to you guys.
You have your coffee with you, right?
Well, I've got some Coke. Coca-Cola.
Okay.
Is it in Bremen or another place, Professor Gabriel?
Oh, you mean the background?
No,
Yes, that.
I mean you are staying in Bremen now or in another
Oh,
place?
I'm right now. I'm at home.
Right, okay. Because
Yes.
your friend Professor Paul just come to Indonesia yesterday.
Who is it?
Professor Paul
Paul,
Darmstadt.
Paul Graham, he's
Oh, Paul
currently
Graham.
in Indonesia.
Right,
Today is
right.
still in Indonesia, ya, Besti ya? Or he was
Okay.
already back.
Okay. Say hello to him from me.
Will do.
By the way, how is the audio quality from my side?
It's good,
It's clear,
very
I think
clear.
good.
Okay, cool. Good to know.
We start in 5 minutes, yeah. Yeah. We are waiting the other
Participants, yeah.
members, participants.
Is it a real background, Gabriel?
Yes, that's a real background.
Wow. Library. Nice.
Right. Well, yes, when I was younger, I used to read a lot. I like reading quite a lot, but
Mhm,
unfortunately, in the past years, I didn't find the time anymore.
Yeah, busy with travel and other works, yeah.
Right, right. Very unfortunate. But well, oh well, what can you do?
We are waiting for others,
Right.
What
students.
kind what kind of book do you
So,
like, Professor Gabriel? Outside
what
of the
kind of?
computer science, maybe novel or something like that.
Yes, for in my pastime for leisure, I like to read novels, like I don't know, classical novels, dramas, sci-fi, that kind of stuff.
Great.
Who is your favorite writer?
Can you say it again?
Who is your favorite
Who is your
writer?
favorite writer? Books writer.
There are so many
J.K.
of them.
Rowling.
It's hard to tell. There are so many of them. One of them is this one, Jasper
Wow.
Ford. He's a
Mhm.
Welsh, UK author. He writes more the funny, more absurdist-like books, but with with a lot of literary allusions. So yeah, but there are so many of them. So uh, how is life in Indonesia going? In Surabaya?
Surabaya. Yeah, Surabaya is hot, I think. But we are now feel better. All people are smiling because we are just win in football competition last night. Yeah. We are beating
Oh,
South Eropa, yeah, last night. So
who
all of
did
Indonesian
you
people now feeling so happy, I think.
who did you beat?
South Korea in ASEAN. What is the
Ah,
competition names? ASEAN FC, IFC.
okay, I see. Cool. So, do people celebrate a lot the
Yeah,
victory
still
in
in
football?
semifinal. Maybe if it's in final, maybe all people in Indonesian, yeah, will
Okay,
celebrate. It's,
I see, I see.
it's just the
Well,
first history in our country. Yeah.
I see. Okay, cool. Well,
Before
then all the
we
best of
never
luck.
come to semi-final. It's just
Right, all the best of luck.
thank you. Besti, you have told Pak Bambang, Besti. We will start.
Sorry.
You have told Pak Bambang. Pak
Yeah,
Bambang,
yeah. I did it. He will join us soon.
But we haven't see him in the
Let
list.
me call him. Yeah.
Okay, because we want to start in 3 minutes maybe. Yeah.
Mm-hmm. Okay, it looks like screen sharing is working too. I think.
Professor, maybe we start with the opening remarks first, yeah, and then after that, I will give the time to you.
Right.
Okay.
Pak Bambang will join us.
Okay, we are waiting, yeah.
He's on the way.
So can you see my screen?
Yep.
Sounds good.
Ah, this is Pak Bambang.
This
Okay,
green
then.
screen, this landscape.
So yes,
Hmm.
you should see my slides.
Yes.
Okay.
Does it work? Okay, cool.
Assalamualaikum Pak Bambang.
Are you going to play a video, Gabriel?
Yes, occasionally.
Okay, maybe you could try.
Mm-hmm.
Hello, Pak Bambang. Good afternoon.
Hello. Good
You
afternoon.
can start now,
Hello,
Pak Bambang.
Gabriel. How are you?
Pretty good. Thank you very much. How are you?
Fine. Alhamdulillah.
Okay. Let's start in 2 minutes, yeah.
Here's the video playing.
Okay, yeah, it's working. Nice.
Okay.
But without sound?
No, I think my
Maybe
videos
when
don't
you
have
share,
sound.
the sound is mute. Oh no.
I think all of my videos do not have sound.
Okay, then it's fine.
Mm-hmm.
Okay, we can start now. Now, everyone.
Let me jump beginning.
Wait.
Okay.
1 minute, ya.
Tuh anak-anak diminta nyalain kamera, Pak, biar mukanya kelihatan.
Everyone. Participant, maybe if you have a camera, you can turn on, ya, teman-teman, ya. Okay, now exactly 2 p.m. I think we can start, ya. Pak Afid, Pak Besti, Pak Bambang, ya. Okay. Okay. Yeah. Good afternoon and good morning in Germany to all of our participants and lecturers. All. Alhamdulillah, in this beautiful afternoon, Indonesia, we have one great discussions talk show, yeah, in our agenda, yeah, this moment. So in this session we have maybe 1, 2, 3, three part. The first one is opening and continue with the remarks from our vice director, and after this maybe we will continue to the main session, that's discussion with Professor Gabriel. Okay, and the last is closing. So before we open the
one opening speech also from Pak Hafiz, ya, after Pak
okay.
Ya.
Yeah, two remarks, yeah, two opening. Okay, before we start, we pray each other, yeah, in order that this program will be running well. Al-Fatihah. Bismillah. Thank you. Okay, for the next session is the opening remark. It will be delivered by our vice director in academic, yeah, Pak Bang Sumantri, ya. Pak Bambang, time is yours.
Yeah.
Maybe 5 until 10
Thank
minutes.
you.
Okay.
Thank you, Pak Siti. Good morning, and Prof. Gabriel. Finally, we meet again here, even in Zoom, via Zoom. So last year we met at IS, and hopefully we will meet again in IS this year. Yeah. Thank you very much, for your willingness to share with us here today, to share knowledge with us here, and also in Indonesia now it's in afternoon, so good afternoon also to all of the student that join and also our colleagues lecture in PENS. So today we'll have what is it like? I think it's a good what is it knowledge that can be shared with us about fundamental immersion interaction. Yeah, and then this topic I think is very related to the one of our program and department here, and hopefully Prof. Gabriel can share with us maybe the current the current issue in this topic also, that some of us maybe can be use this knowledge to increase our capacity here. And Prof. Gabriel, hopefully through this moment also we can nurturing our relationship between PENS and also the Bremen University. And here, not only sharing knowledge, but also maybe we can continue to another collaboration, for example, in research, something, another collaboration. And I think Dr. SD can be the anchor in PENS to make another collaboration with the Bremen University through Professor Gabriel also. And I don't know, Pak Ziki, maybe he has a plan to continue study over there.
Yeah,
And then
we have already connect with Professor Gabriel. We are still design a proposal.
Yeah.
Still in discussion, Pak Bambang.
The scholarship.
Yeah.
Hopefully, Prof. Gabriel can give a good view, about the current issue that are related to the immersion technology or other that related to this issue also. And thank you very much to Professor Gabriel. On behalf of PENS, we say that thank you very much for willingness to share current knowledge regarding the immersive topic. I think that's all. Thank you very much, and hopefully we'll have good topic, and then we have a nice presentation from Prof. Gabriel. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Dr. Bambang, our Vice President in Academic. So, and the second remark will be delivered by our study program coordinator. It will be Mr. Hafid. Okay, Mr. Hafid, time is yours. I think still mute. Okay.
Okay, Pak Sigi, sound.
Okay.
Okay, Assalamualaikum, good afternoon. Selamat siang, the Honorable Pak Bambang, Head Vice President of Academic, the Honorable Bu Hesti, Senior Lecturer in Department Multimedia Kreatif. I would like to express my appreciation to the organizer of this event for help us make this seminar come true. And Bu Hesti, thank you very much for leading the team to create the seminar. And thank you for Professor Gabriel for sharing your time with our lecturer and student. And then today's seminar, we will learn about the fundamental interaction technique, and we will learn about the interaction principle. So this is related with our our program. I'm sure today will be fun and full of learning, and I hope this event can help us increase our knowledge. I think this is all for me. Now I will leave the Pak Ziki to start the first agenda. Okay, thank you, Pak Ziki.
Okay, thank you, Mr. Hafid, for the great remark. Okay, before we continue to the main session, maybe I would like to read you guys. I will spill you all biography regarding Profesor Gabriel Zachmann. So, Professor Gabriel Zachmann is today as a professor in Department of Computer Science in University of Bremen in Germany. Yeah, now he is a member of organization committee of several conference, EuroXR, yeah, 2022, Euro VR 2019, and so on. And also he is member of the conference committee, EAAA VR in various roles. Yeah. And also he member of the executive board of the EuroXR associations, associate editor of the Visual Computer Journal, and so on. Many professional service he has been done. And the other things, he is also head of the examination office for the study program digital media in the University Bremen since 2013, and member of the committee for the development of study program digital media in University Bremen. And also he is a dean, dean of students for the faculty mathematics, computer science, and mechanical engineering from 2008 until 2012. Okay, I think this small spiel, spill things about Professor Gabriel biography. So I will split our discussion today with two sessions. Maybe first time is speech or delivering the material from Professor Gabriel. After that, we continue to the question and answers. Okay, maybe we start, Professor Gabriel, with 14 minutes, maybe around 14 minutes for delivering the material. And then after that, we continue to the discussions, question and answer. Okay, to Professor Gabriel, time is yours.
Okay, thank you very much, Zeki, and thank you very much, Hesti, and all the others for having me here. I hope you can understand me clearly. If not, or maybe at some later point the audio becomes bad, please let me know. First of all, I would like to thank you all very much for inviting me to this lecture and in this seminar series. It's a great honor to me. I would also like to express my gratitude again for inviting me last year to the conference, IES conference. And that was a very great experience. And I agree that I would be glad that I would be very happy if the collaboration and connections between our universities can continue and foster. So having said that, and without further ado, let me dive into the actual lecture itself. So here's an overview of the contents. It's a very brief overview and it's a very short lecture. So I apologize that I cannot touch on all the different aspects that are connected with interaction techniques in virtual reality. But I'm hoping that you can get a little bit out of this lecture. And yeah. So with that, let me dive into the material. Here's an overview of the field of VR. There's, as I said before, many more fields. I will very briefly touch on a few areas which you can see here highlighted in blue. So first of all, we have visual rendering. I'm sure you're all familiar with head-mounted displays, which was arguably one of the first true VR displays. On the right-hand side, you can see basically the long way or the history that we have come with head-mounted displays. So if you compare today's head-mounted displays to those that were used in the first wave of VR, you can see it's really quite a difference. Don't need to go over the technologies. I think the advantages, I'm sure, are relatively clear to all of you. So we have a true surround display with 360 degrees field of view. We have very good immersion, at least in theory. We can have very large working volumes, especially today with the untethered head-mounted displays. So they have a lot of advantages, these displays. However, let me just highlight here very quickly that head-mounted displays are not the only displays that allow to create virtual reality and virtual immersion. So on the left-hand side, you can see what we would call a workbench. It's basically a tabletop surface which is projected from below. Usually, at least, it's projected from below, and you can still have a bit of immersion if you do head tracking for the user. On the right-hand side, you can see a similar kind of display. It has two display surfaces, one table and one basically wall that creates more immersion, and you have lots of different names for these kind of things. So these are basically stationary displays, what we would call immersive projection technologies. Then there's the basically full-fledged immersive projection technology, which is called the cave, usually. So that means you have a small room of walls, and on the right-hand side, you can see a schematic of this kind of room. The size is usually 2 by 2 meters or maybe 3 by 3 meters. And each wall is basically projected onto by one projector. Sometimes you need mirrors to increase the path length. On the left-hand side, you can see one person standing in such a cave. And the nice advantage, of course, is that you don't need to wear bulky headsets, but instead you just need a pair of small glasses. Sorry about that. I'm pretty sure that you have all heard about stereoscopic projection. And this means that we project two different images onto for the user. And that's necessary, of course, because we have two eyes. And here in the following, I would like to clarify really quickly an important concept that is important for all kinds of virtual realities and interaction. And that is the concept of the disparity. On the right-hand side, we have a schematic of the two eyeballs of the user. So we have a left eye that's here, and we have the right eye that's here. We see the two eyeballs from a bird's eye view, basically. And here's basically the pupils of the eyes. So these pupils basically render then projections of the world surrounding us onto the retina. So here on the back, here's the back of the retina, and here you can see the projections of this little green cylinder in front of the user. And maybe you will notice that the projections are not on exactly the same place on the retina. So for instance, if we consider now this other object here, the gray cylinder, it will be projected onto different places on the two retinas of the user. So the green cylinder is projected pretty much at the center of the two retinas, because that's the object that the user is fixating. However, the gray object is projected for the left eye to the left of the green projection, and in the right eye of the user, the gray object is projected to the right of the green object. So there's a difference. And that is true pretty much for most of the objects in the world surrounding the user in this situation. And this basically, this difference in the projections, that is called the disparity. So we have different distances of the projections from the center of the retina. And we can actually put some numbers to that. And this is basically then, we could in theory calculate that. And that is the difference in the two angles of the two projections. Incidentally, we can get this difference in angles much more easily by considering those two angles here. Incidentally, it happens that we can calculate the disparity with this very simple formula. And yeah, basically this is also allows us very easily to measure the disparity by just measuring these angles here. Now, maybe allow me to just make one more remark. I just mentioned that most objects are projected onto different locations on the retina. That is true for most objects, but for a small part of the objects, they are projected onto the same points on the two retinas. And here I have basically made a little construction. So if you basically take this point here and prolong it through the pupil to some point here, and I take the corresponding point on the other retina and prolong it through the pupil, I will end up here. And that means that an object here at this black spot here in space, that object would also project onto the corresponding points on the retina. And so we have a whole surface of points in space where the projections will end up on the same points, on the corresponding points on the retina. And this is called the horopter. And that is basically all the points in space that we perceive as points with zero disparity, which means that we will perceive those points in space or these objects in space as objects that have the same apparent depth like the green object. Okay, so that is a little bit about stereoscopic projections. Now, stereoscopic projections are nice, and I showed you earlier these immersive projection technologies, the workbench, the L shape, the cave, basically all kinds of projections on some surface that is in space, like a large projection screen, for instance. And it turns out that there's a slight problem with that, which you should be aware of if you're using these kinds of displays. And that's what I would like to show you here. I call this usually the one man or one woman show problem. So on the right-hand side, we have a schematic of a projection surface. So that's this surface here. We see the surface again from a bird's eye view. On the left-hand side, we can see the user and the two eyeballs. Let's assume that we have a virtual object. That's this grayish object here at the center. And it's being projected onto the surface with two images, as we usually have to do. And so these two objects are then projected into the eyes of the user. So that's fine, and the user will perceive it at some depth, hopefully exactly at this depth here. Well, if everything goes well, that will happen. However, now let's consider a second user. So if you have a projection surface, like a large screen projection display, usually there are other users around, and they also are going to view the virtual scene on the projection surface. So here's second user. And now let's consider where this user will perceive the grayish object. So all that we need to do is we have to basically follow the paths of the projections into the user's eyes. That's what these green lines signify. They meet at some point in space, and as is this point here. And as you can see, the green user will see the grayish object at a different point or at a different place in space. Ideally, the green user should see the grayish object at exactly the same point in space. But here with projection surfaces like caves and so on, this does not happen. At least not automatically. And this could create a little problem because this means that users will not have the same coherent virtual workspace. So assume that we have this situation that you have a stereo display wall, several users standing in front of it. One user is wearing the glasses that are being tracked. You can see the tracking markers here as these little balls. And I'm going to roll the video on the left-hand side now for you. And now the camera is moving away from the user that is being tracked. And maybe you can already see what's happening. The user that is being tracked is pointing at a specific location in the virtual scene. However, the other user, which is represented by the movie camera here, the other user will not be able to perceive where is the user pointing at. So the tracked user is pointing at a specific point, but all the other users which are not tracked will not see where he's pointing at. And ideally, what you would like to see is what you can see now, the video on the right-hand side. So if the second user, which is now moving away and to and fro from the tracked user, so the second user ideally should be able to perceive where the user is pointing at. And this can be done, but unfortunately, I don't have the time to go into the details how to achieve that. I just wanted to highlight that you should be aware of this problem if you're going to use these kinds of displays. Okay. Next, I would like to talk a little bit about user interfaces in virtual reality. So in general, in the area of user interface research, there are two main categories how you can approach the design of user interfaces. And one approach is to try to make the user interface as natural to the user as possible. So hopefully the user interface then resembles what the user is familiar with from everyday life. The other category or the other school of thought argues that, well, in virtual reality, we have so many opportunities, so why not utilize as many opportunities as we can and try to make a user interface that maybe is not familiar, but allows the user to do all sorts of magic things that increase the efficiency of the user. And so these are two different categories of user interface and two different schools of thoughts. They both of them have their advantages and disadvantages, of course. So, for instance, the challenge with magic interaction is that it could increase the cognitive overhead for the user. The good thing with the natural interaction is the usability. Users can learn such user interfaces very quickly and easily. So that is what we call usability. However, then the challenge with those user interfaces is to allow the expert users to be efficient too. So novices can learn the interface quickly and easily, but experts would sometimes like to take shortcuts or do things more quickly. And that is then a challenge for this kind of user interface. In addition, what we would like to achieve is an efficient interaction in all kinds of user interfaces, which would then lead to what we call user performance. User performance can relate to a number of characteristics like precision, productivity, speed, task completion times, and so on. Here's an example, maybe a counter-example of an intuitive user interface. It's from everyday life. Maybe you have seen this kind of door too. So we have a simple door, and with some of the doors, at least in my university, we cannot just pull the handle. We have to find some button which is somewhere to the side. In this case, it's here. And there's a famous human-computer interaction researcher who said, when a device as simple as a door has to come with an instruction manual, even a one-word manual, then it is a failure, poorly designed. Okay, so let me skip that really quickly. But instead, I would like to talk a little bit about interaction metaphors. So in user interaction design in virtual reality, we have two different aspects that we need to consider. The first aspect is the interaction task. So the task basically means what is the user trying to achieve. And then there's the other aspect, which is the metaphor or the technique. That basically is about how the user can achieve it. And these are two very different concepts, and I'm pointing this out specifically because in my experience, sometimes students confuse the two, the task and the technique. So one is about the what, the other is about the how. So here's a table of examples. We don't have to go through that table now here in detail. You can look at this later for yourself if you want. So for instance, here's a very simple example. If you have a timer, right? So for instance, if you want to start the timer and you have as a tool, you have the hourglass, that would be your interaction device then. And the interaction metaphor or the technique to start the timer is turn the hourglass. So turning the hourglass is the interaction technique. The interaction task would be to start the timer. So hopefully that can highlight this difference by a simple example. So in the following, I would like to show you a few techniques about a frequent task in VR. The task is what we usually call navigation. Navigation in reality is comprised of two different things. One of them is the wayfinding, and the other is the locomotion, the actual moving forward. So the locomotion means that we travel through space in our case, virtual space. We try to cover some distance. We try to maneuver the viewpoint or the viewing direction. The wayfinding is more a cognitive task where we try to find a specific place, maybe in an unknown building or in an unknown city. In virtual reality, we usually say or use the word navigation, but in virtual reality, we still usually mean only this part here, the locomotion. And I'm going to use the term navigation henceforth now too. So what we usually use in VR is what is called a taxonomy. I would like to show you this by way of an example with the navigation. So we start with the task. In our case, it's the navigation. And then we try to break it down into smaller subtasks. So for instance, the navigation could be broken down into, for instance, the subtask of specifying a direction or a target. And then we need to specify a navigation speed or an acceleration. And for specifying the direction, we can basically continue with this breaking down and break it down into even smaller subtasks or different ways how to specify the direction. So for instance, one way how to specify the direction could be pointing into a direction. Or we could basically use the viewing direction of the user or the eye gaze direction, and so on and so on. And we can break down this even further. So for instance, the pointing direction could be done by using the user's hand, or it could be done using any other kind of object or tool, and so on. I hope you get the idea. Same thing for specifying the acceleration or the velocity. We can break this down into all these kinds of subtasks and sub-subtasks. We don't have to go through this now. I think you can do that for yourself if you want. There's one thing missing in this tree of subtasks. You can see this here at the bottom. And what could that be? What did I leave out so far? Well, it's basically what we would call the triggers. So with all these subtasks and the task itself, we need triggers. We need some kind of a condition that starts the navigation, stops the navigation, maybe starts the speed or the acceleration, and so on. And again, you can break this down into more and more subtasks. Again, I don't have the time here to go through all that. I just wanted to highlight here that such a kind of a tree of tasks and subtasks and sub-subtasks, that's what we call a taxonomy in VR research. And this is a great tool to explore the design space of an interaction task. So whenever you need to design an interaction technique, it really helps to, first of all, come up with such a taxonomy, and then maybe you pick your path through that tree. So basically you pick that for the direction, then maybe you pick that path for the speed, and maybe you do this for the triggers, whatever. So it's a great tool to help you specify the design, to explore the design space. In the following, I would like to show you one set of techniques, and that's called the point and fly metaphor. The idea is that basically the head tracking controls the camera or the viewpoint. The user's hand controls some kind of a carpet, and the idea is here that what you can see in the top right, we basically picture the user standing on a flying carpet, if you will. And this is basically then the head tracking, or this controls the head tracking. And the hand of the user basically then controls the direction or the speed of this flying carpet. At the bottom right, you can see a schematic drawing of this metaphor. And this is what we usually then implement in the scene graph. And this means that the user's head is basically controlling here the viewpoint. The viewpoint is basically underneath a node in the scene graph, which is the flying carpet, and that's controlled by the user's hand. I don't have the time to go into further details about this. I just wanted to show you that this point and fly metaphor comes in many different guises. So here you can see, unfortunately, the quality of the video is very bad, but here you can see a navigation technique that is a point and fly metaphor, except maybe at first sight you wouldn't recognize it. So you see here a user who is hanging in some kind of straps and harnesses, and the user is basically moving forward by making these kind of swimming movements. The user is wearing a headset, so the headset is controlling the viewpoint, and the swimming movements basically control the speed and the acceleration of the flying carpet. So this is a point and fly metaphor too. And I just wanted to highlight with this video that sometimes, that you can do a lot of different techniques with this point and fly concept. Okay. Here is another example of an interaction, a navigation technique. It's kind of similar to the point and fly technique, except that here we basically grab the space, and that's why it's called scene in hand. So the user has two controllers. Of course, the user is also wearing a headset. Usually it could also be done with a stereoscopic projection screen. And I'm going to roll the video now for you, and I think that will show you very intuitive how the technique works. So with the two controllers, the user is grabbing points in the virtual space. And when they pull then those points, then basically they are moving the whole virtual space forwards or backwards. And you can even do something like rotating the whole virtual space. Again, that's done by grabbing 2 points in space and then rotating those points around each other. And so I am hoping that this video can show you very nicely the scene in hand technique. Okay, let me show you very briefly, or touch very briefly onto another large area in interaction research. For the past 10, 15 years, this has been a big and large research topic in virtual reality, and that's about selecting objects. On the desktop, I'm sure you're all familiar with that, or it's basically, you don't even think about it anymore. You do it with your mouse, of course. You click on something, you move your mouse pointer, you click, and then the object is selected on the screen. In virtual reality, it doesn't work as simple as that. At least there are more difficulties and challenges in 3D space than on the standard desktop. So what researchers usually do is they break down this task into different subtasks. So again, we have this concept of the taxonomy. And again, this is called task decomposition. So first, the first subtask is to switch the selection mode or this selection on. Then we have to identify some object. This is the main part, if you will, of this whole thing. And because it's so important, it gets its own name. It's called target acquisition. Especially in the literature, if you look into the psychology literature, it's called target acquisition. Or sometimes it's also called pointing. Then the user has to confirm or cancel. That's another kind of trigger that we need. And at all times, what we want to give to the user is feedback. We always need to give feedback to the user so the user knows where am I in this little script of phases of selecting objects. Just to show you that there's also a little bit of math involved in interaction research. There's a very famous law. Maybe you have heard about that in some other courses, maybe an HCI course. It's called Fitts law. And in virtual reality, there's something similar to Fitts law. It's basically a user model for distal pointing, basically pointing at things in the distance. So what we have is a controller. That's this thing here. That's the controller that the user is holding. Out of the controller, usually we have a ray that is pointing into space or going through space. And then what the user sometimes, well, maybe the user would like to select this object. So the user has to move the pointer or turn the pointer from this direction to that direction. The object at the distance subtends a specific angle. It's called omega here. And basically the angle through which the user has to move this controller is called, this angle is denoted by delta in this drawing. And now if we know those two angles, we can basically, or there's a famous law that tells us how much time will the user need to complete the task of acquiring the target. And the law is given here by this equation, as you can see. I don't have the time here to go through the reasoning why this law is reasonable and makes sense. But it shows basically that if the angles delta become larger, then the target acquisition times become longer. Also, if the object becomes more tiny that the user wants to acquire, then again, target acquisition times become longer. Okay. I don't have the time to go through a lot of selection techniques, but I wanted to show you one technique really quickly. It's a technique that we have developed in the past few years. And that is basically a technique that is arguably, or we argue that it's useful in cluttered scenes. And it also works in dynamic scenes. So at the bottom, you can see a number of test scenes that we usually use in this kind of research. And as you can see, some of these scenes are rather dense. The objects are rather dense. So here, for instance, we have a lot of objects in a closed space. Also here, lots of objects. And here too, here. And then if you imagine that some of these objects might even be turning or moving around, then selecting a specific object becomes even more challenging. What we would like to avoid is a break in presence. Maybe you have heard about this concept. we would still like to allow a precise selection of a specific object with an intuitive ray-based metaphor. Ray-based metaphors are nice because they are very intuitive to the user. And of course, we wanted to work with cluttered scenes well, but also efficiently in uncluttered scenes. And so here you can see a video that shows you how this works in practice. So what we do is basically, first of all, there's the standard ray-based technique. So you can see the feedback. And now you can see the technique that works with, as you can see, increasing temporarily the sizes of the objects close to the ray of selection. And you can see how this works with different scenes, with different distances. So you can ignore the red text, of course. That's just for that was just a debugging text. Here you can see how it works with another test scene, right? As you can see, objects are dynamically scaled up so that it's easier to hit them with the ray. And as you can imagine, this increases usability a lot. It also increases precision for the user and overall satisfaction. So in total, it basically decreases the task completion time. And with all that, allow me to just show you one last thing that uses a number of these techniques in an application. So just for the last 1 or 2 minutes, I'm sure you're all familiar with visualization of data. And if you have high dimensional data, then one standard technique is to use what is called scatter plots. And with lots of dimensions, you then need what is called a matrix of scatter plot. So for each and every of these small scatter plots, you basically pick 2 of the dimensions and basically plot your data as points in that 2-dimensional plot. Now, another very famous technique to visualize such data is parallel coordinates. You can see on the right-hand side an example how this looks like. So you can see all the dimensions here of your data. In this example, it's 7 dimensions. Each dimension is represented by one of these axes. And then you draw basically lines for each and every data point. You draw one line through all these axes. And now what we would like to have is something that is a bit more intuitive maybe. And here, virtual reality can be a very nice and important tool. So the idea is here that we basically consider the axes of our plots as virtual objects that users can move around in virtual space. And they can also have different semantics depending on whether you basically move them close to each other in parallel, or if you move them close to each other orthogonally. That's the basic idea. And I guess it's best if I show you a quick video about this. And I think that conveys very nicely the idea of this immersive data visualization. So here's the user. And as you can see, they can grab the axes. So they can pick 2 dimensions. And if you move the 2 axes close to each other, then basically they become either a scatter plot or a parallel coordinates plot. And you can now move more axes and put them together. So this way you can create a scatter plot matrix. You can move them orthogonally to each other. This also creates a scatter plot, but this time it's a 3D scatter plot. And you can now create all kinds of fun visualizations like this one. This is a parallel coordinates plot in space. And you can do all kinds of crazy things like this one. As you can see, lots of parallel coordinates plots, but in a funny arrangement. I'm not sure this is really that useful, but hey, it's fun, and you never know, maybe users can make great use of it. So yeah, this again shows a parallel coordinates plot with just two axes. You can do all kinds of interesting things with that. So this is what is called querying. So you take one axis and query all the other axes with it. And this is a very efficient way how to visualize high-dimensional data in virtual space. That brings to the end of my very brief talk on interaction techniques. As I said before, it's really just scratches the surface of everything, but I'm hoping that you got an idea about all the cool and interesting research topics that we have in virtual reality. And that, yeah, that's basically the end. Thank you all for coming. If there are questions, of course, I am happy to answer them now, or if you want later, if you want, you can send me an email. But I'm happy to answer any kinds of questions you might have. And I'm, of course, also very grateful for your attention. Thanks a lot.
Okay. Thank you, Professor Gabriel. So very philosophistic science, yeah, that you have talk about interaction, yeah. And okay, guys, today and now we are moving to the next sessions is question and answers. Maybe anybody want to ask directly to Professor Gabriel, you can using raise hand, or maybe if you are shy, you can write in your chat, yeah. So I think there is one question here, Professor Gabriel, in chat, yeah, from Fauzan, yeah. Okay, my name is Fauzan. I want to ask a questions. Nowadays, the newest VR headset like Oculus Quest, yeah, he means Oculus Quest 3 and Apple Vision have mixed reality capability with the hand tracking feature. Is the navigation of the mixed reality similar to virtual reality, or it is different? Because in the mixed reality, we also interact with the real object. So the question is that navigation of mixed reality is similar with the virtuality or different? Maybe you can answer.
Thank you very much for the question.
Yeah.
Thank you very much for the question. Excellent question. Yes, with augmented reality, things are a little bit different in many cases. They are different, especially for the navigation, but also, yeah, well, especially with the navigation, as you correctly pointed out. So with augmented reality, we usually use more basically the direct physical walking. So we don't do very much of this point and fly metaphor because that usually confuses users if the virtual environment is somehow shifting around and the real environment that they can see is not. What you can do is with the Vision Pro is you can basically dynamically switch the see-through on and off. I think that's also possible with the Quest 3, if I remember correctly. So if you want to cover longer distances in the virtual environment, I think what you should do is you should basically then block the video or the see-through while you're navigating in virtual space. Yes, I'm hoping that answers your question. If not, of course, feel free to follow up. But thanks again for the excellent question.
Okay, thank you, Professor Gabriel. Is there a feedback from Fauzan? It's good answer. Okay, we move to the next asker. Yeah. So, there is a Dr. Hesti. Miss Hesti, you have raised your hand to ask. Okay, time is
I
yours.
raise my hand.
Yeah.
Okay. Thank you, Professor Zachmann. I try to be professional here. Okay. Yeah, thank you for the talk. It was very great and a very clear explanation. I was wondering about the taxonomy technique that you mentioned before on your slide. It was based on taxonomy Bloom, right? So I I couldn't imagine how this taxonomy could facilitate the exploration of the science space to be an interaction test. Do we have, as a designer, do we have to use this taxonomy to systematically break down and categorize these components and separate it into some interaction tasks, and how this process will help user or the designer to understand the relationship, dependency, and opportunities in this design space? I couldn't imagine that. Maybe you could give more explanation about this.
Thank you very much for your question. You're right that if you haven't done it yourself, these taxonomies, then maybe it's a bit surprising, but that is indeed a standard technique that people use when you have to design a new interaction technique. So what you do is you start with the task. In the example, that was the task of navigation. And then you try to come up with all the possible ways that you can possibly imagine. How can you break this task down into smaller subtasks? And that is sometimes it's a bit difficult to do because at this point you shouldn't think about devices very much yet. The devices come later.
Okay.
So at this point, you break down the task into subtasks, and then again, you want to break it down into even smaller subtasks. And then at some point, you start to think about how can you actually map these very small subtasks onto small things on your devices. So you always have some kind of device, like you have maybe hand tracking, you have maybe speech recognition, maybe you have a eye gaze tracker, you have a head tracker, you have, I don't know, maybe specific buttons, you have controllers, maybe you want to build a new device for some specific subtask, right? So there's lots and lots of possibilities that you have. And it's rather it takes a bit of time to basically explore all these different possibilities and write them actually down as a tree, like I have shown you with the taxonomy. But once you have that, then you have a better and clearer understanding what are the different characteristics, what are the different opportunities, which subtasks or which techniques can be matched, right? So what you do is in the end, you basically mix and match. You take one piece out of one branch of your taxonomy, one little leaf, and then you mix and match those. And then you try to basically find the best combination of these little subtasks and try to map them onto devices.
So it's not necessary to think about how to connect these tasks with the device in the beginning when we design this taxonomy, including this interaction task. Okay.
Yes, correct. Yes, that's correct. And that, in my experience, that's actually a kind of a challenge for the students, because students like to think about devices immediately when they think about interaction tasks. But you're absolutely right. One should refrain from thinking about concrete devices in the beginning. They come only later.
Okay, thank you.
Thanks a lot.
Okay, thank you, Mrs. Hesti. Maybe I can continue to ask question around a taxonomy interaction. Yeah. So I ever tried using ManuMotion. You know, ManuMotion SDK, something like that. That I have connected to the Unity in interaction ER. Yeah, ER interaction. But I think up to now there are not found the I mean the proper interaction with a free hand. What do you think, Professor Gabriel? Is it a prospect to make interaction with free hand, or we have to use something like gloves interaction and so on? Because when I have tried to make interaction using ManuMotion SDK in Unity, and we use simple project, something like that's not, I have no experience. Sometimes is flip and so on, something like that. Yeah, what is your suggestion about that?
Right.
Yeah.
Thanks a lot for your question, Mohammed Siki. And you're absolutely right. Freehand interaction is challenging in reality and also in augmented reality. Because there are only so many gestures that you can remember. I didn't have the time in my talk, but there's a lot of evidence that users can remember maybe three different gestures with their hands, but not much more. And so it's quite a challenge to design interaction techniques that work only with the free hands, since you're working basically in midair, right? And so you don't have any usually you don't have physical objects that you can grasp. In my mind, what you should try to do is to make the interactions as intuitive as possible, which usually means that you should probably try to present to the user some kind of a virtual object that conveys the interaction that the user can do. So for instance, if the user wants to select something that is at a distance, then you could present to the user maybe something like a laser pointer as a virtual object. Then they can grasp that with the standard grasping, right? The grasping gesture, and then they can point at things. So I think that would be a good way to implement all kinds of interaction techniques without any devices, without any physical devices like a controller. But yes, you're absolutely right.
Okay.
It is kind of a challenge.
Yeah, challenge and very tough, I think. Up to now.
Yes.
Because we
very
are still
tough.
using camera, yeah. Camera is something
But
that
then,
just
yes,
from several points, yeah.
exactly. You could do that
Okay.
too. But challenges are good. That allows us to do research and publish papers.
Yeah. I hope so. Okay. So they from Fuad, yeah. Fuad, you wanna directly to deliver, or I will read your questions? I have to read. I will read. Yeah. Okay. I have a question about VR. As the professor explains earlier, everything greatly depend on the perspective and visions. Yeah. However, how does this relate to the comfort of user experience? Some people still feel a bit dizzy when using VR headset. And I'm curious if this is influenced by those calculations. Yeah, is the question, Professor?
I understood only half of the question. I'm sorry about that. So it's you're asking, or the participant is asking about cyber
The
sickness.
participant.
Exactly. Yes.
Yeah.
It's about cyber sickness. Okay. There's in the chat. Thanks a lot.
Yeah, in the chat. Yeah.
Maybe about motion sickness, something related.
Yes.
Comfortable of user experience about how using a VR headset. Sometimes he's dizzy and something like that. How is the calculation to make maybe better?
Yes. So cyber sickness has become a big topic in virtual reality research in the past years. In particular, since there's now all these VR games and the commodity hardware, so a lot of users are now using VR. So and the companies, obviously, they have a very high interest in reducing cyber sickness. So yes, cyber sickness is a big issue, and it seems that there's a number of people, like 10% or so, who get these symptoms, and it's very hard to mitigate those symptoms. It's extremely hard. One of my PhD students, he gets cyber sick even with a regular desktop game. There's no VR involved. They're just playing a game on the desktop PC, and still they get cyber sick. So some people have really are really very sensitive. There's been a lot of research, and there are a number of techniques what you can do. So for instance, one technique is to limit the field of view. So usually in VR, we want to have a big field of view, right? So that we can increase the immersion and the presence. But if people get cyber sick, it helps if you can reduce the field of vision. And so there's been quite a bit of research on that. Also, some people have experimented with artificial horizons. So basically, you present to the user some kind of a horizon in the distance, as kind of a virtual horizon, and that also seems to help. But it's still a big challenge, and I think there's still quite a lot of opportunities to do research here, how to best mitigate cyber sickness. Right. I hope that answers the question.
Thank you. Any feedback
Thanks
from
a lot.
Fuad? It's enough? Okay. Any other questions? All participants? Okay. I will read once more from chat, yeah. Okay, maybe we pass to Hilmi first. Hi, Mr. Gabriel. I want to express my gratitude for your which one? Okay, sorry, it's scrolled. For your lecture, my name is Hilmi. Now I have a question that has been on my mind. Can VR mode with a smartphone offer an experience comparable to that of dedicated VR devices? Okay.
Okay. Thanks a lot for your question.
Okay. Yeah.
That's also a very interesting question. There are two answers to that.
Yeah.
If you're thinking of doing VR with a smartphone like the Google Cardboard does, then I'm pretty sure that for the foreseeable future, we will not have the same experience for a number of reasons. And one reason is that I think smartphones will always have less compute power than regular headsets, regular VR headsets. You know that the Vision Pro, for instance, it has a complete M3 processor inside, and I think smartphones always will have less compute power. Also, the The real good VR headsets will always have more sensors embedded than a smartphone, you know, a smartphone that you stick into a cardboard device. The other answer is if you're thinking about doing augmented reality with a smartphone, like some kind of a see-through, you know, augmented reality, where you hold your smartphone and then you can see through. That's, I think, a very nice setup to do augmented reality in a number of applications. So, for instance, we can think of maintenance, car at a car shop to do maintenance of a car. I think in this cases, a smartphone can be a very nice and very helpful tool to do augmented reality. So yeah, in this case, it's probably fine. Okay.
Okay, thank you.
Thank
Next
you.
question maybe from Fauzan. He also asked about what software or game engine do you usually use for developing the VR application and other immersive technology? I ever hear from you use not Unity, Unreal Engine, yeah.
Unreal.
You can explain maybe, Professor. What game engine or software that you suggest to develop some immersive technology applications like that,
Right.
including VR? Yeah.
Yes, right. So yes, thanks a lot for the question. In my lab, we are using only Unreal Engine. In my mind, it's better to focus on one engine and get really familiar with that engine and you know, go into all the small and intricate details of the engine so that you're master of the engine. I chose Unreal because I felt that the visual quality of the Unreal Engine is better than Unity. Also, I had the impression that with Unreal, you can basically plug into the engine and basically control the engine more directly using C and C++ code. Now, I'm not really an expert in Unity, so maybe you can do that with Unity too. But yes, we are using Unreal for all kinds of things. We connect it to robots. We multi-users with Unreal, and so yeah, it has proven to be a very good game engine for us. Does that answer the question?
Yeah. Once more from Putri. She asks about the term of immersive versus interactive in VR that you mentioned. Yeah, I think immersive will be interactive, but interactive not always immersive. I don't know. Maybe Professor Gabriel can explain about what is immersive and what is interactive in the immersive technology term. Yeah.
Yes. Thanks a lot for the question. That allows me to clarify terms. Sometimes, yeah. Sometimes I might not be very clear. Yes, you're absolutely right, Ziki. Immersion is always somehow interactive, but not everything that is interactive is immersive. So we can basically talk about human-computer interaction on the desktop very, very well, and it's a complete research area by itself, but it's not immersive. And so in virtual reality, we usually talk about immersion, which means how much of your senses is basically covered by the computer. And then there's also the interaction, which basically talks about the techniques that you need to use in an immersive environment. And there's also a third term. It's called presence. Maybe you have heard about that. That is a very psychological term that talks about how much do you feel that the virtual environment is real. So there are different levels of presence, there are different levels of immersion, and they are sort of connected to each other. But yeah, maybe that's a short answer to your question. I'm hoping that it answers it somewhat.
Yeah, is there a feedback from Putri? Is enough, I think. Yeah, if you have a feedback, you can write in your chat, or maybe you can talk directly, yeah, using open your mic, with open your mic. Okay, for the next question from Isan Nuro, he asked about the adaptation of VR will be like in 5 up to 10 years. What will adaptation, yeah? What technology will be adapted maybe of VR will be like in the next 5 up to 10 years, and approximately when will the use of VR be adapted, such as smartphone and maybe and so on. Yeah, I think the main question is what technology will be adapted in VR in for the future, yeah, 5 until 10 years later. Yeah.
Thank you very much for your question. Also, I'm not sure I can give you a full, definitive answer to that. Looking into the future is always risky, and a lot of people try to forecast the technology developments and uptake and failed. So my hunch is, I can only give you some speculative hunches here. My hunch is that virtual reality is here to stay. It will be adopted for many different applications in many different areas. I'm sure it will be adopted at some point in education. It will be adopted in all kinds of areas like medicine, healthcare, maintenance, maybe remote driving. It's a standard tool in the automotive industries already. So in the automotive industries, they are doing a lot of different things with VR, like checking designs, like checking the style of a car in VR, and so on. It's also being used in the mining and oil and gas industry. So I think it's here to stay for all kinds of industrial and business applications. It could also replace maybe Zoom and this kind of video call that we're having now at some point. I'm relatively positive that will happen in 5 to 10 years' time, maybe more 10 years' time. But yeah, it's hard to tell. If you're asking about the metaverse, I'm not so sure about that. At least
Maybe I
not
can continue
the way Facebook is trying to position it. Sorry, Ziki.
Yeah, Professor Gabriel, maybe I have some question about the future technology. How about the headset? It will become like a usual glasses, something like we wear today. Yeah, maybe we know now what HoloLens, yeah? We have HoloLens headset that's very big now. Maybe can it will be transformed, become the usual glasses, something like we are using today. Yeah? It can be.
Yes. Yeah. Again, that's a tough question. I'm sure we will see a continuous shrinking and reduction in weight of the headsets. Whether we will live to see headsets that are as small as a pair of sunglasses, I'm not so sure about that. It's a pair of sunglasses obviously is the dream headset we all would like to have. But that is probably 50 to 100 years away from now. But I've seen a lot of interesting research publications that go directly into the direction that you're asking, Ziki. So there's all kinds of novel and really cool optics. The optics, that's one of the major stumbling blocks right now that prevent the shrinking of the headsets. So yes, I've seen a lot of really cool research in the optics, in the physical optics field, but yeah, before that becomes a real actual commodity hardware, I think that will take, I don't know, maybe 30 years. It's hard to tell.
Yeah, I know this belong to optic major part, yeah, that make a research,
Right.
not in
Yeah.
computer science. Okay.
Yes,
Okay.
yes.
Yeah, I have no another question in the chat. Anybody want to ask directly? All participants? Or Bu Hesti, Pak Afid, it's enough?
From me, it's enough.
Okay. So before we close this discussion, maybe you can give our closing remark, Professor Zachmann.
Yes,
Yes.
thank you very much, Ziki and
Yeah.
Hesti, for inviting me, and of course, thank you very much for everybody else at PENS for making this happen. I'm really proud to be here, and I'm thanking all of you, of course, for coming to this lecture, for your attention. Also, thank you all much for your interesting questions and the lively discussion that we had, even though it's remote. Of course, in-person discussion is better usually, but I'm still happy that we could have this remote discussion. So thank you all very much.
Thank you. Thank you, Professor Gabriel.
Thank you,
I hope we
Professor
can
Gabriel.
continue our collaboration
Thank
and
you.
discussion, yeah, for the next agenda. Okay, for all participants, I think this is the last of our sessions. So I'm as the moderator, I'm apologize with if you have many mistake from me. And thank you. See you on the
Foto
next
dulu, Pak.
what?
Itu belum buat laporannya, buat foto dulu.
Ah, yeah, also, yeah. So before we close this session, we have photo together, yeah. We have screenshot we must give. Okay, to all participants, you can open your camera. I will make a screenshot for some pages, yeah. So for all participants, I hope you can open your camera, make a smile, and then we can screenshot. Okay. Okay, open all participants camera, please. Okay. One. Okay, give your best smile, guys. 1, 2, 3. Okay. Moment. Oh. 1, 2, 3. Okay. Next page. Next page. Okay. 1, 2, 3. Okay. Moment. Hold on. Next page. Oh, the third page is there is no participant that open the camera. I think enough until the third page, yeah. So thank you for everyone. So once more, I'm as the moderator. I apologize to you if I have a mistake in delivering this program. Thank you, Professor Gabriel. See you for the next session. Yeah,
Thank you, Gabriel. Thank you.
Yeah,
Bye.
I hope we have still in discussion, yeah, for the next agenda and collaboration.
Exactly,
Thank you.
yes.
Yeah, good morning and afternoon, yeah. Assalamualaikum
Thank you
warahmatullahi
very
wabarakatuh.
much. Yes.
Have a nice day.
Have a nice day.
Have a nice weekend.
Yeah.
Have a nice weekend. Bye.
Yes. Bye-bye, everybody.
Bye.
Bye.